Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 63rd Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 63 is powerful digit counts. The 5-digit number 16807 is equal to 7 to the 5th is also a 5th power. Similarly, the 9-digit number is a 9th power. All of that. How many n-digit positive integers exist which are also an nth power? So, this one's going to be a little bit interesting, I think. Because the parameters don't really exist. So, what we're going to have to do to find the solution to this, there's a few different ways we could go about this. I think the more efficient way is to just sort of start with the number 1, and maybe not the number 1, because 1 to the anything is just 1. So we know 1 to the 1 is a 1-digit positive integer, which is also a 1th power. But it will never be more than that. And then 2 to the 1 is a 1-digit positive integer, which is a 1th power. So we kind of already know about 9 of them, 1 through 9. And it'll get interesting starting with the number 2. So I'm going to go ahead and see if we can do sort of look at 2 to the 1, 2 to the 2, 2 to the 3, etc. And when we start getting a number of digits that is greater than the power, I think, is how we would want to do it. So let's see if we can find programmatically how many of these we can find. Grabbing our favorite little timestamp. Okay, so I'm just going to create a count equal to 1 for 1 to the 1. I don't actually know if it means us to count that. We shall see. And then for n, let's just say for x in range 2, 1, and we'll only go to 1000. This may or may not get us the correct answer, but and then for n in range 1, 2. Honestly, doing this as ranges doesn't really make sense. X equals 2, n equals 1. Actually, not there. And then I'm just going to say while true, actually, for this first one, I'm just going to say while x is less than 1,000, so that we have a break. N is equal to 1, and then while true, let's see, x at the n is equal to x star star n. Length. I don't actually think this is going to work. I think I'm going to have to add a string conversion, but I kind of want to try it out. And then if length is equal to n, count plus equals 1. And then, let's see, if length is greater than n, then I think we might be done. So I'm going to build that in first. Okay, so length greater than n, meaning if we get to a number where it is larger than the power we are raising it to. And then I'm just going to print count. This might come out looking like an infinite loop. But let's go ahead and give it a run just to see. Okay, so I just kind of wanted to see if that would work, and it did not, so now I know. Okay. Okay, so this is taking a significant amount of time. Ah, yep. So this is why I add things like this. Okay. Let's put that as less than. See. Okay. We also forgot to increment x. Comment that out for now. Let it run through. Okay. I'm going to do... Okay, let's change this back to for loops because we're just going to artificially cap everything at 1,000. So for x in range to 1001, for n in range 1001, see where that gets us. It probably is going to take a bit to run just because we're running through effectively 1,000 times 1,000 numbers, so 1,000,000 numbers. And there's probably a good way to cut this a bit shorter. But I'm not entirely sure what it is. Okay, so we got 49. Which sure is a thing. I'm just gonna go ahead and check whether 49 ends up being the correct answer. I have a feeling it is not. I could be wrong. Okay, so we did this a super simple way. All we did is we guessed, hey, maybe we only have... Maybe x to the n is only going to be within 1,000 and 1,000. Just check every single one of those and count all the ones that are in-digit numbers with an nth power. And that very naive approach just happened to take only 42 seconds and give us the correct answer. I feel like there's probably a better way of doing this. This was just a stab in the dark. But it worked. So I'm gonna call that it for today, and I'll catch you in the next one.